And myself, Nupur. I am going to tell you about Newton's law, which is very important nowadays in our daily life. So, we all wish for the apple to be a coconut when the laws are made. But sorry to break your malevolent fantasies, the apple never fell. At least, not the way we were told it did. A good publicity stunt, I did say, if it were even a face back then. So I suppose you all have heard of Isaac Newton. Yes, the one who made all those tricky laws, gave all the man impossible to remember equations. In the 17th century, Sir Isaac Newton explained the fundamental principles of motion through his famous three laws of motion. These laws describe the relationship between the motion of an object and the forces acting on it. They form the foundation of classical mechanics and help us understand how and why objects move, stop, or change direction. From the falling of an apple to the motion of the planet, Newton's laws are applied everywhere in our daily life as well as in science and technology. Thank you. At the end, my teammates Arohi, Vaidehi, Urvashi, and Rohan Sonavne will explain briefly on Newton's three laws.
Inertia is an inherent property of all materials. According to Newton, inertia is the fundamental property of all objects to resist a change in their state of motion. Take this bottle for example. Right now, it is at rest. Once we apply an unbalanced force, or in simple terms, push it, we can notice that it changes its state of motion, of being at rest to moving. After a while, though, it comes back to rest. This is due to friction coming into play, another force that changes the bottle's state of motion from moving to coming to a stop or at rest. The first law of motion, thus, is stated as every object at rest or in a state of uniform linear motion continues to be in the state of motion unless acted upon by an external unbalanced force.
Let's move to the second law of motion. This law relates the external unbalanced force that we already familiarized ourselves with a new term, momentum. So, before we dive into the words, let's imagine this. If a baby run at you at the speed of 2 km per hour, unlikely it's hypothetical, you can stop them easily, one hand more than enough. Now imagine if that was a sumo wrestler. Good luck on stopping him. Warning, you are about to turn into a pancake. So momentum is a basically the universal way of saying the heavier and the faster dude, the more regret you will feel when it hits you. And since we already covered the heavier part, let's look at the faster motion bit. So take this ball here, an unbalanced force we have already met. So we nudge the ball lightly and the ball moves only a little slowly distance. On the contrary, if we push it a little harder, it seems to go faster. And now, why is that? Cause force is applied on the object is directly proportional to the momentum of the object. To sum up, momentum is a mathematically mass time velocity, and thus momentum of an object is directly proportional to the force applied on this object. The second law of motion states that the momentum of an object is directly proportional to the force applied on that object when it is unbalanced.
Newton's third law states that for every action, there is an equal and opposite reaction. For example, when you walk, you push your feet backward on the ground, the action, and the ground pushes your feet forward with an equal force, the reaction, which propel you forward. Newton's third law of motion. Force is a push or pull acting on an object resulting in its interaction with another object. Force is a result of an interaction. Force can be classified into two categories: contact force, such as frictional force, and non contact force, such as gravitational force. According to Newton, when two bodies interact, they exert force on each other, and these forces are known as action or reaction pairs, which is exerted in Newton's third law of motion. Third law of motion states that when one body exerts a force on the other body, The first body experiences a force which is equal in magnitude in the opposite direction of the force which is exerted.